Can you tell us a little bit about some of the challenges in the radio environment at airports?
Sure. In this particular case, most of what's happening is not at the passenger level. So when the bag starts out, it most likely in most U.S. airports anyway would be covered by some distributed antenna system right on that level. But those distributed antenna systems are certainly not designed to be covering the bowels or the underneath of the airport. So once that bag leaves that level, then it's essentially going into a basement type environment. And the DAS maybe has a little bit of coverage there, but then, the bag will reach some holding room and it's, I don't know, half mile underneath the airport or something like coming in from the sides of the terminals. And so there's very little signal there. So maybe you end up with a failed handoff from, say, the DAS to whatever external macro site is around, or you reach some sort of no service level. So that was somewhat common. And then the other sort of challenge in this environment is, depending on the size of the airport, and then, you might run into a situation where the closest tower, simply because it is an airport, is a mile away or 2 miles away because of the height of the tower needed or so on. So, out on the tarmac is not, coming from an RF engineering background, is not what most engineers would have designed that tower to serve. It was designed to serve the terminal maybe, or an adjacent highway or a road leading into the airport, but certainly not to serve where the planes are landing. And so a lot of times we would find very low signal levels, or perhaps depending on the size of the airport, if it's something very large like Dallas or Atlanta, for example, then you might have a tower on top of a parking structure, but again, then it's out in the tarmac and sort of seen as a wide open area where you might run into a lot of interference as well.